for 5.3 day 1, and today this is going to be working with double angle formulas. So again, remember when you are taking a quiz or a test, you will be given these formulas, so you don't have to worry about having them memorized, you just need to know how to use them. So the first double angle formula we have is the sine of 2a equals 2 times the sine of a cosine of a. So for this one, we are just going to be plugging in those values that we know. Looking at example 1, if the sine of a equals 3 over 5 with a in quadrant 2, find the sine of 2a. So, like we discovered last week, we can just draw this in our triangles. Whoops, that's not a good triangle. So sine is opposite over hypotenuse. We can use Pythagorean theorem to find our missing side. 5 squared minus 3 squared equals 25 minus 9, which is going to equal 16, and we take the square root of that and we would get 4. Because this is in quadrant 2, that's going to be negative 4. Now we can start filling in our formula from above. We are looking for the sine of 2a, and that's going to be equal to 2 times the sine of a, which we already know is 3 over 5, times the cosine of a, which we can find from our triangle, of being negative 4 over 5. Now we're just going to simplify by multiplying this all together. So I can take 2 times 3 times negative 4. 2 times 3 is 6 times negative 4 is going to be negative 24 all over 1 times 5 times 5, which would be 25. And that would be our final answer. And we do want to leave it as a fraction, giving us the exact answer. All right, now let's do it again. We are trying to prove that sine theta plus cosine theta squared equals 1 plus sine of 2 theta. So we're going to go through and simplify this. First, you want to choose one side. So why don't we do the left side just to start. So we're going to start by foiling this out. Remember, because it's squared, it's the same set of parentheses being multiplied by itself. We would end up with sine squared theta plus sine cosine plus sine cosine. So that would be 2 and then plus a cosine squared. Well, if we think back to our trig identities that we know 1 is equal to sine squared theta plus cosine squared theta. So we can replace this with a 1. And if we look back at our identity that we learned today, 2 times the sine of a times the cosine of a is equal to the sine of 2a. So we can replace this with plus the sine of 2 theta, which is what we were trying to get to. Remember, when you are proving these identities, you want to work on one side of the equation until you get to the other side of what you were trying to get. Okay, our next one. We are going to prove that sine of 2x equals 2 cotangent of x all over 1 plus cotangent squared of x. So for this one, you are going to want to choose which side you are going to work on, and then you are going to use your identities to simplify. For this one, I'm going to choose the left side because that one looks a little bit more complicated than the right. So we have 2 cotangent of x all over 1 plus cotangent squared of x. One of our trig identities from the first day that we were going over these, the Pythagorean ones, is 1 plus cotangent squared of x equals cosecant squared. So I'm going to see if that'll help us simplify by changing the bottom to that value. So we have 2 cotangent of x all over cosecant squared of x. Okay, the next thing I'm going to do is change it to sine and cosine, and also change it to a multiplication problem instead of a division problem. So we would have 2 cotangent is cosine over sine, and then multiply. Secant squared is the same as 1 over sine squared. So I'm going to multiply this by sine squared of x all over 1. Then we can simplify 1 sine squared with the 1 on top. So we would be left with 2 sine of x times cosine x. And it's okay to switch the order and put sine in front of cosine because multiplication is commutative, so the order doesn't matter the way we write it. And then this looks like the identity that we just went over today, with sine of 2a equaling 2 sine of a cosine a. So we know that this will simplify to 2 times, oh, sorry, I forgot what it was. Oh, just the sine of 2a. Sorry about that, no 2. And then that would be our answer, which is what we were trying to get to on our proof as well. So there you go. If you need a moment to pause it and then copy the rest down, you can do that now. So one thing, for sine, there's only one formula that we will use. Cosine, there are a few different ones. So we have 3 different forms for the double angle formulas when it comes to cosine. One of them we use cosine and sine. The second one we use just cosine, and then the third one we use just sine. So depending on what information you're given, it might make more sense to use one of these forms over the other. You will still get the same answer, just different forms might be more work depending on what you are given in the problem. So if we start and we look at this example we are given, example 4, we are trying to find the sine of a equals 1 over the square root of 5, and we are going to find the cosine of 2a. If we look, we were just given sine of a, so for this one I am going to use the third formula because that one is the one that has only sine in it. So I'm going to go ahead and plug in the information I know so we can find the cosine of 2a. So that is equal to 1 minus 2 times the sine squared of a. So we're just going to take 1 over the square root of 5 and we're going to square that. And then we would have 1 minus 2 being multiplied by 1 over 5 once we get that squared, which would then be 1 minus 2/5. And then our final answer would be 3 over 5. And that gives us the cosine of 2a for that angle that we were given. Okay. Now we can move on to our next example. This one is a little bit longer. We are trying to prove the cosine of 4x equals 8 times the cosine to the power of 4x minus 8 cosine squared plus 1. So for this one, the first thing we're going to want to do is choose which side that we are going to be working on. And for that, we are going to be working on the right side because that one is the most complicated of the two that we are given. So if we look at the right side, I'm just going to rewrite that over here. 8 times cosine to the power of 4x minus 8 cosine squared x plus 1. For this one, you'll notice this is only working with cosine. So, actually, I'm sorry, we're not going to work on this side. We're going to work on the other side, cosine of 4x. So for this, we can use our double angle formulas. And this one, we're going to want to use the second one because we are only given cosine in this example. So we can write cosine of 4x as cosine 2 times 2x and apply our double angle formula since the right side is written in terms of cosine only. So when we do that, we know this is equal to cosine of 2 times 2x. We can use our double angle formula, which is 2 times cosine squared of a minus x. So we can write this as 2 cosine squared of 2x, and this is going to be our a value, minus 1. So it is okay to have a product inside of what we're taking the cosine of. So this one we have cosine of 2x instead of just x or theta. So then once we have that, we can then again use the double angle formula because we still have a 2 in there. So we can apply this double angle formula again inside of the parentheses. So we have 2, and then we're going to have parentheses, and we still have this minus 1 on the outside. And then on the inside, we're applying that double angle formula again. So that's going to be a 2 cosine squared of x minus 1. Now that we have this, and this is going to be squared. Then we are going to FOIL out these parentheses that are squared here. So we're going to have 2 times 2 cosine squared of x minus 1 times 2 cosine squared of x minus 1, all minus 1. So we're going to FOIL that out, and when we do that, we would get 2 times 4 cosine to the power of 4x, and then we would have minus 2, which is going to be minus 4 cosine squared of x, plus 1, and then minus 1 at the end. Then we're going to want to distribute out this 2. So we're going to get 8 cosine of 4 to the power of 4x minus 8 cosine squared x plus 2 minus 1. And the last thing we will do is simplify by combining any like terms like we have at the end. 8 cosine to the power of 4x minus 8 cosine squared x plus 1, which is what we were trying to get to back on the left side of our problem. And there is our answer. For today, your homework assignment is listed here. I will also have it posted in Schoology for you. If you have any questions, tomorrow hopefully I will be back and we can go over them together. And then we will continue on with the second half of this lesson. There will be no quiz tomorrow because I am gone today, and we will just have to take one next week. Have a great day.